Welcome back to our lesson on Introduction to Trigonometric Ratios. And what we'd like to do is figure out in this right triangle that's shown, what is the sine of z, the cosine of z, and the tangent of z. And we can solve the right triangle first using Pythagorean theorem or Pythagorean triples. And once we have the three sides of the right triangle, we can figure out what is the sine, cosine, and tangent of this acute angle z. So I'm going to use a Pythagorean triple, and I know that the most famous triple is the 3, 4, 5 right triangle. So I believe that this side here, side YZ, is 4 units in length. Now that I know that, to determine the sine of z, I use the opposite over the hypotenuse. The opposite of z is the side directly across. The hypotenuse is always the longest side in any right triangle. So the sine of z is 3/5, 3 over 5. The cosine of z is the adjacent side over the hypotenuse. The hypotenuse is definitely going to be 5. The adjacent side is 4, so the cosine of z is 4/5. The tangent of z is the opposite over the adjacent. So tangent of z, 3 over 4. Let's take a look at our next example. It's the same right triangle, but we're asked to classify angles x and z. So when we look at angle x and we look at angle z, we realize these are not congruent. If they were congruent, these two legs would be the same. So they're different measures, but they must add together to equal 90 degrees. Because if I already have a right angle, and I know the sum of the three angles in any triangle is 180 degrees, these two angles, x and z, are complementary angles. Now let's determine the sine of z. Again, sine being the opposite over the hypotenuse. That would be 3/5. What about the cosine of x? Well, cosine is adjacent over hypotenuse. It's the same hypotenuse, 5. The adjacent side to angle x is 3. And we notice something interesting, that the sine of z and the cosine of x, these two complementary angles, are equal. Okay, let's take a look over here. What about the sine of x? Remember, sine is opposite over hypotenuse. Sine of x is 4/5, because 4 is the opposite side, 5 is the hypotenuse. Cosine of z, adjacent over hypotenuse, same hypotenuse, so same denominator, and the adjacent side to z is 4. So once again, we see that the sine and the cosine of complementary angles are equal. So that's worth noting. Let's take a look at example frame number 8. Write a similarity statement, it says, and then solve the problems. Okay, so in order for me to write a similarity statement, I have to prove that the triangles are first similar. And all I see is one congruent angle in each triangle. I could do side, angle, side. I sure could. Side, angle, side, noticing that there is a relationship, a proportional relationship between the heights of these two triangles and the bases. The scale factor from one triangle to the other is 2. Whenever we have a scale factor of 2, or a scale factor of anything really, we know that the triangles are similar. And looking at the hypotenuses, 5 times 2 is also 10. So I used side angle side, but you also could have used side side side. Either one is good. X, Y, Z. Notice the way we're traveling down those letters, starting at X, going down the short leg, and then traveling down the longer leg, is similar to triangle L, N, M. And that's by side, side, side. The sine of Z, remember sine, SOHCAHTOA, sine, opposite over hypotenuse, opposite over hypotenuse, 3/5. So now we want to pay attention to the sine of Z. Sine of Z. Z is the last letter in this triangle name. And what about the sine of M? Also the last letter. Well, over here, the sine of M, here's angle M, opposite over hypotenuse, 6/10. The 6/10 simplify? It sure does. I can divide both numbers by 2, and I get 3/5. So this tells me that the sine of corresponding angles in similar triangles are also equal, right? So the sine of Z and the sine of M are equal. Alrighty, we are looking at the next example. And this time we have a right triangle DEF, which is shown. We have been told that there's a similar right triangle STR, which is not shown. We want to figure out what is the cosine of angle E. We can figure that out from the diagram, cosine. Adjacent over hypotenuse. So here's angle E. Adjacent is 24. Hypotenuse is 25. Now, because these triangles are similar, the cosine of angle E, E being the middle letter, should be equal to the cosine of angle T, T being the middle letter. So I don't need to see triangle STR. I just need to know what is the cosine of E. It's 24/25. Therefore, the cosine of T will also be 24/25. So these are some big but subtle ideas related to trigonometry. In this lesson, we went over a lot of information, and so it's a good idea to go back to the different frames of your notes and write down some key bullet points. So pause this video and then come back and let's see if you hit every main idea that I'm about to share with you. Pause the video first and write down your thoughts. Okay, so one thing, hopefully, is that you know that trigonometry is that branch of mathematics that deals with the relationship between the ratio of the sides of a right triangle and its angles. So we're talking about a right triangle, and we're talking about the ratio of sides. The three main trig ratios, did you remember to think about this? Sine, cosine, and tangent with their abbreviations. How about SOHCAHTOA? Was that worth writing down in your summary slide? It's a memory device to help you remember the ratios of sine, S, cosine, C, and T for tangent. And the sine of an angle and the cosine of its complement are equal. That's an important detail. And we also learned through these last two slides that the trig ratio of corresponding angles of similar triangles are equal.